Hello everyone, so we are starting off with the first idea of O-level chemistry, and that is kinetic particle theory. Let me just, yeah, okay. So now what is kinetic particle theory? You might have studied this thing in your earlier classes as well. So the idea behind kinetic particle theory is that, as per the definition says, the kinetic particle theory states that all matter consists of tiny particles, atoms, molecules, or ions in constant random motion. Now, what does that really mean is that in kinetic particle theory, or in terms of the real reality that we are living in, all of the things that you see, like your cupboard, like your door, like your refrigerator, everything is made up of something that we call as the matter. And if you have this question that what is matter? Matter is basically anything that has mass and occupies space, right? Occupies space. So everything that you see around you is made up of what? Is made up of matter. Okay? Again, that could be a door, that could be a refrigerator, anything. All of those things are made up of matter. Now, these matter, or what you can call, is that this particular matter, this is made up of tiny particles. And these tiny particles are always in a constant random motion. Okay, it's a simple math basically, right? What is simple math? Everything that is around you is made up of matter. That matter is made up of tiny particles, and these tiny particles are always in some constant random motion. Okay, and the reason why you see this diagram here is because we are going to be looking into ideas of how does this actually happen in different states of matter, because you have a solid state, you have a liquid state, and you also have a gaseous state, right? So what you need to understand is how does this movement, or how does this constant random motion actually happens across all of these particular states, right? That's the idea that we're looking forward to. So the next thing in this lecture is, or next thing in this video is, the idea of solids. How does this random motion happens in solid? One thing that you also need to know, by the way, is kinetic particle theory. What does kinetic tell you? Kinetic tells you that this is going to be involving some sort of energy, right? And kinetic basically means, whenever you see the word kinetic, that means movement. What does that mean? That means movement. Okay, so now again, getting back to the point, in this whole topic, in this whole chapter, what we're going to be studying is basically energy changes. Energy changes within solid, liquid, and gases. What happens when a solid goes from a solid state to a liquid state, and from a liquid state to a gas state, and vice versa? That is the idea that we will be looking forward to in this particular chapter. Okay, now let me take this figure down so that we can, have some space and do this idea a lot better. Okay, so we have three states of matter. We already know that. We have a solid state, we have a liquid state, and we also have a gaseous state. But what we're trying to understand are some ideas about these states of matter. For example, now in this particular solid thing, that as you have seen, it's a very rigid structure, or you can say it's a very structured structure, right? It is a very ordered structure. So the first thing, now what I'll be doing is writing some points, and we'll probably have 6 to 7 points of each of these states of matter. So the first point about solids is that solids has or solid are the particles in solids are very closely packed. Okay, and you can see that. So the particles are very closely packed. They also have something that we call as a very ordered arrangement. A very ordered arrangement. And then if I talk about kinetic energy, again, I told you that this chapter is going to be concerning us with energy. So when I talk about kinetic energy, and when I talk about movement, because what did we say? Now, a question that you might have in your mind is that, let's say we have a refrigerator, let's say we have a door. Now, a door is a solid material, right? And by the definition, KPT says actually that everything that is around you is made up of tiny particles, is made up of matter, and matter is made of tiny particles, and those tiny particles are always in a constant random motion. So the question might be that how does the solid door is moving? How does the particles inside a solid door is moving? And that's the idea that we are discovering today. So the way it's moving, you see, movement in all of these three matters happen differently. So in solids, we call this movement as vibrations. So always remember that no matter you see a solid, liquid, or a gas, even in a solid, at all times the particles inside the solid, the particles that make up the solid, are always moving. They never stop. And that movement in solid is something that we call as vibrations. Okay, that is your idea. So movement in solids is something that we call as vibrations. Now, one more thing that you need to know is something that we call as the forces of attraction. Now, what is forces of attraction? Basically, the particle that you see here, like this, or these particles here in solid, you see, between these two particles, like this, and like this, they have something that we call as the forces of attraction. That's what's keeping them together. So these two particles are together because they have very strong forces of attraction. These two particles are together because they have got very strong forces of attraction. So all of these particles, like this, now even from the middle like this, all of these particles have very strong force of attraction, and that's why they are very close to each other. Okay, I hope you got it. So the forces of attraction, I'm writing it as FOA, are very high in solids. That's your another idea. Now, as for the kinetic energy, we just saw that. Now again, we just say that in solids you have what? You have got vibrations. That means vibrations means the kinetic energy is going to be lower. Why? Because it's not moving. It's not entirely moving, right? If I compare it with solid, liquid, or gases, you see, if you look at it in gases, look at the particles here, and what you also need to know, and we'll go very deep in this chapter as well, is that gases have very high. Sorry, gases. The particles inside gases move a lot. The particles in liquid also move, but the particles in solids, they do not move. They vibrate. So remember, anything that moves. What did I say at the top? That anything that moves. Whenever you hear the word movement, that means kinetic energy. Or whenever you heard the word kinetic energy, that means movement. So because gases, the particles inside gases move a lot, that means that they have a lot of kinetic energy. The particles in liquid, they don't move a lot, right? So that means they have kinetic energy, but they have lesser than gas. But when we talk about solids have very low kinetic energy, because again, their movement is based on vibration. Their movement is not based on freely moving particles. They're just vibrating, and when they're just vibrating, that means that the kinetic energy is very low. Okay, so the kinetic energy in solids is very low. That is your one more point. Okay, and yeah, I think these are enough points that you might need to know. And there are a few points as well, but I'll show you a table for that, so you'll understand much better. Now let's look at for liquids now. For liquid, what you have, the first idea is this one. Now the particles here you see in liquid, for liquid the particles, they're still close, but not that close, right? I mean, there is some distance between them. So the word that we can use for them is they're still closely packed, or you can say less closely packed, less closely packed compared to solids. Okay, that's what you can say about them. Then the next thing is their arrangement. So if you see, this was a very ordered arrangement, right? Very structured. But this is not an ordered structure. So what you can say about liquids is that they have a disordered, they have a disordered structure. Okay, that's the second point. The third point is they don't have vibrations now, because you see, here you don't have vibration. What we say about liquid is that liquid have particles like this, and these particles can move past each other, not entirely freely, but to an extent it can move past each other. So liquids have particles And you can say that they don't have vibrations, but again, they can slide past one another freely. The fourth point is their forces of attraction. Now, when the particles are close, you need to remember, when the particles are close, the forces of attractions are very high, just like in solid. But when the particles are disordered like this, they are a bit far apart. That means that the forces of attraction are weaker. Compared to solids, they are weaker. Okay. And the next thing that you can mention is about the kinetic energy. Now, the kinetic energy is going to be higher because the movement of particles in liquids is more, right? So the kinetic energy is higher. That's your 5 points about liquids as well. And you can also go the same way like for gases. Now I'll quickly go over that. Gases, they are not closely packed. You can already see that the particles in gases are very far apart. Okay. Second point is the particles are not in an orderly manner. This is a very disordered manner. So you can say no order at all, right? So very disordered manner. Point three is they don't have vibrations, but what they have is a lot of kinetic energy because the particles are far apart. Okay, the particles are far apart, so they have a lot of kinetic energy, and the movement is a lot. Okay, so you can say that particles move freely. The fourth point is the force of attraction. Now, as as distant the particles are, right? As far as they are, the more further the particles are, the forces of attraction are going to be weaker, right? And the kinetic energy is going to be very high. And that's a general idea about solid, liquid, and gases. But you still have some things that we need to do, and that is, and I'll put a table here.